So this video is on floating point arithmetic, and yeah, so let's take a look at this program here. This has to do with, this example is from problem set number 3. And what are we doing? We're creating an array that can contain type doubles, and there's 9 spaces. We're using this for loop to fill it up with random numbers, and this here is going to generate a random number from 0 to 500, and dividing it by 1000 will give you that number, that random number, in a decimal place format. So like this might be one example, point might be another example. And so what we're doing here is we're generating randomly batting averages, right? So a decimal place with 3 digits following the decimal place, and the range is going from 0.000 up to 0.500. Okay, so that's our range. And then what we're doing here is we're printing everything out. Okay, so let's go ahead and run that and see what happens. We get this, right? Beautiful, it's perfect. Okay, so then now what we're going to do with that is we are going to add 0.2 to each element in the averages array, right? So we're adding 0.2 to it, and this here is floating point arithmetic, right? So we have a decimal place added with a decimal place, and let's see what happens here. Oh, and this second for loop here is printing everything out, right? So let's go ahead and run that. And you can see this one follows, right? It was 472 and now it's 492. That makes sense. This is 355, now it's 375. And so all of these look good. And then when we get to this one here, you can see we got the 2, the 8, and the 4. That looks good. But at the end, it adds like an insignificant number far on down in the decimal places, right? Same thing's going on here. And yeah, and if I run it over again, you could see that it's random. It appears to be a random insignificant number that's placed in the decimals. So what is going on there, right? You might be asking yourself, like, well, what's going on? First of all, you're asking, well, you want to fix it, first of all, but the first thing you should be asking yourself is what's going on. And if you wanted to, you can go ahead and watch this YouTube video. Just go ahead and search for that. And he goes over it. It doesn't go over it like the best way, but he kind of goes over what's going on. We're going to have a guy coming in, and he's going to go over exactly what's going on, and he'll explain to you exactly why that happens. And so the short of it is, or the short story is, that the physical structure that the computer is using to store these floating point numbers cause that insignificant decimal place to be added onto the number when you do arithmetic sometimes. Okay, depends on the numbers that are being I guess, like multiplied or added or subtracted or whatnot. So how do we fix it? Well, what you can do is, whenever you have floating point arithmetic, we can do math.round. Okay, so math.round. What does that do? That rounds up or down the number that you are that you give it as an argument. So we're gonna do that. So that is going to, hold on a second. So first we want to take this decimal place number, and we want to multiply it by 1000, right? So that's gonna, let's take one example here. We got 0.0233, and then we have a insignificant decimal place added onto it. And first we want to multiply it by 1000, right? So that is going to give us 233.000001. And then we're going to do math.round on that. And what math.round does is, if the number is between if we got like 0.0 up to 1.4999999, it will round it down to 1. And if the number is between 1.5 to 1.9999999, it will round it up 2. Okay, so then we're going to do math.round so that we cut this off and we get 233, and then we are going to divide it by 1000.0. We're not dividing by 1000 because that would do integer division, which would give you a 0, because 233 divided by 1000, 1000 doesn't go into 233, right? 0 point something 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 something. So integer division would give you a integer, which would be the 0 truncated. So we want to make sure we do floating point arithmetic. So we're going to put a 0.0 there, make sure the denominator is a double, and then that's going to give us 0.3. So we're getting rid of that insignificant decimal place on the end by using math.round and a little bit of arithmetic kung fu here, right? So let's go ahead and see if that works. Go ahead and save it. And we're coming over here. Whoa. Coming over here, and we're running it. And voila. That floating point error is gone, right? And you might be thinking, well, since it's random, maybe we randomly got the floating point error to go away. So I'll run it again, and again, and again, right? So yeah, so something to be aware of. Floating point arithmetic will get you, and there are definitely questions that deal with floating point arithmetic on the exam. Typically, they reference like Boolean expressions inside of an if statement, and then the Boolean expression like involves floating point arithmetic, so then the expression turns to false, right? Because although it seems like it should be true, like you got x is equal to y, it should be true, but because of floating point error, it evaluates to false because y has like 0.000001 on the end of it due to floating point error. Yeah, so that's about it.